All right. Yep. So this is 5-3, part 3 on elimination. You ready for this, Mr. Ferry? All right. So let's look where we started. We started up here. Okay. If we look at number 5, okay, notice the X's were the same in number 5, right, Kanye? Just look up here, buddy. See how the X's are the same? Right? 4x and negative 4x. Do you see that? Because they were the same, we just added the two equations. Number 6, okay, the 5x and 5x, they were exactly the same, so we subtracted. You okay with that, Ms. Kender? But then we moved into questions like, well, what do we do with questions like number 2? Well, nothing's the same, right? We have for the x's negative 10 and 5x, and then we have for the y's 3 and 6. So I couldn't just add them, or I couldn't just subtract them. So we ended up multiplying one equation by a number to get rid of, so to say, the variable. So we ended up like multiplying the bottom equation by 2, so we would get rid of the x's. Do you remember that, Harshan? But now, how do we do a question like 3? Does anybody have any ideas how we could solve 3? Remember, the name of the game is to get one of the variables the same number. Neve?
So if you multiply both equations by different numbers, say you multiply the top one by 5 and bottom one by 4, so that each one has 3x, you can get rid of at least that variable so you can subtract 5.
Neve, if this was not COVID, I would give you a high 5. So we're going to pretend, ready? Nice job. All right, so Neve said, what we're going to do is we're going to multiply one equation by a number and the other equation by a number so that the variable we're choosing to get rid of cancels out. Now, they're not going to be the same number, okay? And we just have to figure out what that number is. So Neve chose in number 3, the x's. And she said, well, let's multiply the top equation by 5. And that gives me 20x plus 15y equaling 105. Andrew, do you see that? Okay. Do you see why she chose 5? Okay, so Andrew saw it a different way than Neve. Neve saw it like, hey, I want them to both be equal to 20. And Andrew noticed, well, hey, I just multiplied it by the number in front of the other x. Do you see that? So Andrew, that way works perfectly fine, okay? And then in the bottom equation, all right, we're going to multiply it by 4. And Andrew, notice your method still works, right? We multiplied the top one by 5, bottom one by 4. Notice the x was in, or the 4 was in front of the x, and the 5 was also in front of the x, but in the opposite equation. So we're going to distribute that. That gives me 20x plus what? 8y equals 84. And now you can see after doing that, the x's are the same. Got that, Jack? You on the right page? We're on page 13. Okay. So here we have the x's that are the same. So we're going to go ahead and subtract. The same subtract. So 20x minus 20x, they cancel. 15y minus 8y, that's 7y. 105 minus 84, that looks like it's going to be 21. And then I divide by 7, and I get y equals 3. Is everybody with me? Emma, you with me?
Yeah.
Let's see. Jordan, you with me? Jordan's like too busy working at Linvilla, serving out that hot apple cider on a cold day. Good stuff. Good stuff. Ms. Kender, are you with me here? Liam, make sense to you? Liam's probably working out, preparing for next year's wrestling season. I know so, the kid's got dedication. All right, here we go. So I now have y, and we know what to do once we have that. We pick an equation and we go back. Now we have 4 equations. We have the blue, we have the red, and then we have the 2 original equations. I strongly encourage you to pick one of the original equations. And I'm going to pick the bottom original equation. That 5x plus 2y equaling 21. Here's why. In this one, okay, I find it easy to divide by 5s, okay? And I also notice that 2 in front of the y, that's small, it's all positive. I like dealing with smaller numbers, not necessarily bigger numbers. So I'm going to go ahead and draw my arrow to the y. So that gives me 5x plus 2 times 3 equaling 21. So 5x plus 6 equals 21. Subtract 6. Notice we have 5x equaling 15. X equals 3. Apparently. And Neve, I could check that, right? If you're questioning it, you could check it. 3 goes in for x. 4 times 3 is 12. 3 times 3 is 9. 12 plus 9 is 21. Looks like I did it right. Do you guys see that? You see how it was building each time, trying to get rid of the variables? Nate, you okay with all this? Okay. I want you guys to try number 2 on your own. While you guys are doing that, don't forget, early next week, I would probably say like, I don't know, I don't think it's really. Midweek now. All right, we're probably gonna have a review Monday, and then like Tuesday, it'll be a quiz. Okay? Wednesday. I know, all the days start running together.
Check, can you use pencil? I got an extra every day.
Sean, how are the fingers put up? Better?
I can't use these.
Henry doing all right back there? Making progress on this problem? Plug it in. Yeah. Plug it in, check and see if you're ready. I think you are. Yeah, it's free. What's going on? Nope, free. Nope. I did beforehand, but I needed gas anyway, so it's free. Now, my friend asked me to buy him a soda while I was there. That was not free. But it's my friend, so. Yeah. All right. Neve said she got.
I got 5 and -3.
5, -3 is the point. Now let's check. So first things first. All right, Andrew and Neve, you guys had 2 similar yet a little different ways of doing it. Andrew, your way was to multiply the top equation by like the number in front of the variable in the bottom equation, right? Was that your method? And I didn't tell you that. That was perfectly fine. Okay. All right. Neve, yours was like you saw 20 and you try to make them both equal 20, right? So up here, I'm looking at the X's. That's the ones I want to get rid of. I don't know which one you guys chose. You could have chosen the Y's, or you could have chosen the X's. Doesn't really matter. We're going to end up with the same answer. But Andrew, this is what I wanted to point out to you. If we get rid of the X's, do you see how we would multiply the top number by 6? All right, now 39 times 6 is pretty big, right? Now you can do that. You can type it in on your calculator, pretty easy, right? Now, the one thing I do want to mention is this. Do I have to multiply it by 6? No. I could multiply it by 2. Now, Andrew, I'm not saying you're wrong, but do you see why I could multiply it by 2? Because I would get 18, right? So I encourage you to pick a method that works for you. Now, Andrew, I'm not telling you to change your ways. Did you get 5, -3? Oh, you did the wrong page. That's okay. But Andrew, with this, I'm confident through your method, you would get the right answer. Okay. So I want you to kind of choose either like choose Neve's way or Andrew's way. If you don't see what number they go into, do it Andrew's way. Okay. It will always work. If I do 6 times 9, I'm going to get 54. If I do 9 times 6, I'm going to get 54. Notice it's the same number. Has to be. It's the same 2 numbers, right? If you're a little better at this and you can kind of see things and you like dealing with smaller numbers, then kind of do it Neve's way, where you multiply the top one by 2, because 9 times 2 is 18. And the bottom one would be by 3, because 3 times 6 is 18. Okay? So we're going to do it Andrew's way. So here we're going to multiply the top one by 6 and the bottom one by 9. Okay, so I'm just going to distribute this out. 6 times 9, we already said that, that's 54. 6 times 2, that's 12. 6 times 39, anybody know that off the top of their head? 234. Did you do it this way? 234. How'd you get 234 so far? Do you know? Who said 234? Me? Ah. You ready for this? What's 6 times 40? 240 minus 6. Because I want 39, right? 54. That's another way to go. Here, 9 times 6, 54. 9 times 13, a little bit more difficult, right? That's 117. Okay. And 9 times -9 is -81. We're getting rid of the x's. Notice the x's are the same. All right. 54 minus 54, that's 0. They cancel. 12 minus -117 is -105. 234 minus -81. Well, two negatives make a positive, so it's going to be 5 carry my 13 carry my 1, or not 13, 11 carry my 1. So it's going to be 315. Now I divide. Y equals -3. Hey, look at that. Now I'm going to pick one of my equations to plug it back into. I'm going to pick the original top one. It's 9x plus 2y equals 39. Two times -3 is -6. Add 6 to both sides, we get 45. Divide by 9, that's going to be 5. Yeah. We okay with that? Any questions? No questions? We all right? All right. All right, we're going to continue on with these problems. Let's turn to number 3 to talk about Juan. All right, Juan answered all 50 questions on the test. He earned 3 points for each question he answered correctly. He lost 1 point for each question he answered incorrectly. His final test score was 102. The system of equations below describes the relationship between the number of questions he answered correctly and the number he answered incorrectly. Okay. As part of the solution of the system is x equals 38. What does this value represent? I've already heard from you today. Let's go with Drew. What does 38 represent?
The points on the test.
The points? I don't think it's the points.
Oh, the amount he answered correctly.
Yes, the amount he answered correctly. So that tells me he answered 38 questions correctly. Let's think about this way. If he answered 38 correctly, how many did he answer incorrectly? No, not 104. Nope. 12. How'd you get 12? There's 50 questions, subtract 30, you got 12 wrong. So it says the number of questions he answered correctly. Well, that is the right answer. But notice, we got a bunch more information, right? We got the number of questions he answered correctly. That was 38. Number he answered wrong is 12. We could have checked that. You could do 3 times 38, that's 108. Okay, and then I believe it's one. No, that's 138 times 3, 114. So 114, and then we take off the 12 points because you got 12 wrong. Notice that's where we got the 102. All right. Henry purchased X candy bars and Y soft drinks for his friends at a cost of $16. All right. I don't know where he's getting these candy bars, probably Wawa. All right. The next day at the same store, Henry's friend purchased twice as many candy bars and 3 times as many soft drinks and spent $38. Which of the following statements is true? Ooh, that's a crazy question, right? So let's create a system of equations, right? You guys know what to do here? Anybody? Any ideas? All right, I'll read it again. It says Henry purchased, okay, X candy bars and Y soft drinks, right? And it cost $16. The next day at the same store, Henry's friend purchased twice as many candy bars and 3 times as many soft drinks and spent $38. Which of the following statements is true? Henry spent $4 more on drinks than candy. Henry spent more on candy than Henry's friend spent on drinks. Henry spent less on candy that Henry spent on drinks, or Henry spent more on drinks than his friend spent on candy. You guys have any idea what to do? Nobody? Andrew, you're like, no idea. Sophie, any ideas? None? All right. All right, let's try this. Let's write this down. Candy cost. All right. And I'm going to use, I have to use a variable. It doesn't tell me, right? This is going to be the annoying part. Candy cost is going to be, hey, we don't know how much it is. It doesn't tell me how much it is. Okay. Drink cost. Is big. Now, why am I calling it A and B? Well, because in the problem, X and Y are already taken. Okay. And this is where the math magic happens. So let's see where we go. Henry purchased X candy bars. So we have AX. So we have the cost of the candy times the number of candy bars, right? AX. Do you guys see that? Now, it says plus the drink cost, which is B. So we bought Y drinks. So we have BY. That equals $16. Does everybody see where I got that from? AX plus BY equals 16. Now, I have no idea where this is taking me. First time I'm doing it. Okay. Can't say that to the second period, but so we'll see where this goes. All right. Now it says Henry's friend purchased twice as many candy bars. Now I need another equation. So Henry's friend bought twice as many candy bars. Nate, does the price of a candy bar change? No. So it's going to be A, which is the candy cost, times 2x. It's twice as many. Does everybody see where I got the 2x from? Plus, now it says 3 times as many soft drinks. So soft drinks still cost B, but this time I bought 3 times as many, 3y. You guys see where that came from? Equals 16.
said.
Oh, yeah, 38. Good call. Good catch. 38. Any ideas where I could go with this? All right. Let's see. Okay. Yeah, I got it. You ready for this? You ready for some math magic? I think I can do this. Do you believe in me? I don't believe it. Here we go. All right, let's do this. Let's multiply this top equation by 2. That's going to give me 2ax plus 2by. You guys see where that came from? 2ax plus 2by equals 32. Now, in the bottom equation, I have, oh, didn't bring me up. In the bottom equation, I have 2ax plus 3by equaling 38. So I'm going to subtract. Do you see why? If I subtract, these guys are going to cancel out. 2by minus 3by is just by equaling negative by equaling -6. So by equals 6. Okay? Meaning my number of drinks times my soft drink equals $6. So I'm kind of thinking like Henry spent $4 more on drinks than candy. Okay? Henry spent more on candy than Henry's friend spent on drinks. Henry spent less on candy than Henry's friend spent on drinks, or Henry spent more on drinks than his friend spent on candy. So let's see. So I'm thinking that one drink costs, I don't know. I don't know where I'm going with this. It's like, bro, just give up. Me, here's what I'm going to do. I'm going to take a moment. I'm going to think about this. In the meantime, here's what I want you guys to do. Look at the next page. I'm serious. I don't know where I'm going. Look at the next page. All right. On the next page, here's what your homework is. Let me. All right. I need you guys to circle these problems. 11, 13, 15, 17. Those 4 problems. That's what I want you guys to do for homework and to make sure U10 is finished.
11, 13, 14.
On which page?
The next page, what does it say at the top? It's 5.3 exercises. It says page 251. And while you guys are doing that, I'm going to finish this up and hopefully we finish at the same time here.
What are the numbers that we're doing again?
11, 13, 15, 17. And then when you're done, you're just going to take a picture and send it to me. All right, I got it. You ready? You should be impressed. with me. You doubted me. I know you doubted me. All right, so we got it down here to BY equals 6, meaning that Henry spent $6 on drinks. How do I know that? Well, it says BY, remember our original equation where it said AX plus BY equals 16, meaning that Henry spent $6 on drinks. Okay, AX, well, that had to be 10 because 16 minus 6 is 10, meaning he spent $10 on candy. So his friend spent twice as much on candy, so 2 times 10 is 20. And then his friend spent 3 times as much on drinks, so 3 times 6 is 18. Now it says Henry spent $4 more on drinks than candy. That's false. He spent $4 more on candy than drinks. Henry spent more on candy, $10 on candy, than Henry's friend spent on drinks. That was 18. So that's false. Henry spent less on candy that Henry's friend spent on drinks. So $10 on candy, $18 on drinks. I'm kind of feeling that one. Henry spent more on drinks, that's 6, than his friend spent on candy. That's false. So that'd be 6. Thank you. I'm proud of myself. But don't worry, you still have to do those 4 problems and you have to send them to me.